What are the best practices for MTSS? This is a very high overview. This is taken directly from the National Center for RTI, really thinking about what are the essential components. And so you'll see at the center that database decision-making. That should be driving all decisions, whether or not students receive additional supplemental instruction across the tiers. Differentiation in the classroom, thinking about all those pieces. And so moving out, that light gray circle is culturally responsive and evidence-based. And then the other big purple, progress monitoring, again, that feeds directly to the data, the multi-level prevention system, and then of course screening. And when we put those all together, that dark gray is that improves student outcomes. And so really trying to have schools understand, how do we use this data to drive decisions? I've talked to some schools, they're like, yeah, we progress monitor. And I'm like, so what do you do with the data? We progress monitor. Okay, we progress monitor because the school tells us to, but we don't know what to do with the data. Okay, which is why teachers are like, oh, we always do all this assessments and I don't understand the point, because they're not using it to drive any of their instruction and really understanding, what does it mean to differentiate? If I differentiate in core, is that tier 2? No, it's not tier 2. That's just really good teaching. And that's what's difficult. Really good teachers kind of do the MTSS framework on their own. Other teachers really need the practice of, what does my core instruction look like? And how is core different than tier 2? And how is tier 2 different than tier 3? So I really we've used this quite a bit at AIR. But what is MTSS and what is it not? So it's a prevention framework. It's not a program or a curriculum. That's what I often hear teachers say. Well, this didn't work. I need the next program. Yeah, there isn't another next program. We need to be doing what are the components? What curriculum are you using? And how can you adapt that to meet the student needs? For all students, including those students in need of enrichment, not just for struggling students. And how are we providing intervention for students that are above level? And it's more of enrichment versus intervention, but it really is for all students. It's flexible for schools and districts, and that's what's hard. A lot of schools like, where's my MTSS manual? I want to know step 1, step 2, step 3. If you don't have the capacity or the same resources, it's going to look a little bit different. It's collaborative, incorporates a team-based approach. It's not just the responsibility of one teacher. And it's really thinking about, what are those stakeholders? I've talked to some schools, the special educators are like, oh, we're not part of the student assistance team until they go to special ed, then we know about them. Okay, but you have the strategies. How are you not even part of the brainstorming? How are we not pulling everyone in that's a specialist at the beginning to talk through those pieces? Data-driven, multiple valid and reliable data sources. And then my favorite one, framework that can be used to assist with special ed decisions. It's not the pre-referral process. This was created to avoid the wait to fail. And now I go into schools and they're like, I'm MTSSing that student. Well, you're not, it's not a verb. It's a framework. We're not MTSing them in order for special ed. It's to give them the services they need. And then, of course, we get into, okay, so do they have to go to tier 2 first? That's that flexibility. It's not necessarily like, yes, you get tier 2 and then tier 3. Some of our students, they're coming in very low. We got some low babies. They need to start at tier 3. That's that flexible, not a one size fits all. And then I really like this one. The supports are tiered, not the student. It's kind of like our people-friendly language in special ed. We don't talk about a learning disabled child as a child with learning disability. It's not a tier 2 student. What supports are we providing to that student so that they can be successful? And so really thinking through, we may have a student that's doing well in reading and needs some math support. Unfortunately, a lot of our kids that need math support also need reading support. But what about all these other behavioral components? How are we addressing some of those? And so really thinking about the whole child and what supports are needed. What we see a lot, again, this is the ideal situation. About 80% of our students are on level. About 15% need some more support, and 3 to 5 need something intensive. But what a lot of schools struggle with is our students with disabilities. We have done a disservice to some of our kids in special ed. They're receiving tier 2. They're making progress. It may not be adequate. And so we're like, okay, they need special ed. Oh, yep. Well, now they can't receive tier 2. So they're going to go back into the inclusion classroom, which is where they had started, where we said they needed help. They can't receive tier 2 anymore because they're special ed. That's not true. They are all general education students first. And so when we think about what is the role of specially designed instruction and what is the role, how are we still meeting our students' needs in special education? They can still be part of tier 2 instructional groups. They can still be part of tier 3. And so really thinking through those pieces. All right, and then I'm going to turn it over to Paul. So again, that was a very higher level understanding, but now we're going to kind of dig into, so how are we preparing our teachers to go out and to think through those pieces? And then do we understand the implementation? So Paul, I am turning it over to you.
All right, well, welcome everyone. I'm glad to have this opportunity to meet with you, albeit an abbreviated session, so we're gonna sort of jump right into it. The context of this, when Kat approached me if I was available, was sort of a little bit different angle on MTSS in terms of the teacher preparation aspect and how our pre-service programs are prepping adults that are gonna be teachers that come into our MTSS model. So some questions: how deep is our knowledge of MTSS? Are your teachers prepared to differentiate core instruction, understand data, identify students in need of tiered instruction? Are teachers prepared to implement interventions with fidelity collected to drive instruction? And those are kind of big questions there. You know, so my take, one of the things that I'm going to struggle with is not giving my context, what I see, because I'm at Penn State, I'm at a teacher prep program, I'm in the special ed department, and then I see the general ed. And so I'm sort of going to try to talk broadly. In general, I think people have decent understanding of what MTSS is. I think where we really have issues is at the instructional / intervention level. I really think that teachers really struggle with what to do when kids don't get it. And I think that's at the root of everything. That's what we're really trying to address here. Taking these kids that are struggling, give them enough support so that they can move forward and progress. So I think in math, you have unique factors that are different than reading. And one of them is the content of math. The content of mathematics is very different in reading. I kind of like to use this analogy. We always hear that if you get kids reading by 3rd grade, they tend to stay on track, or they're learning to read up until 3rd grade, and then they're reading to learn. Where math is slightly different because math is constantly evolving. There's new content, it's expanding, it's going deeper for basically the entire kid's math career. So there are unique challenges in math. So what I decided, there were a lot of things I could have talked about. I really decided to really narrow in 2. So we know that here are 8 general RTI MTSS recommendations. I kind of wanted to zero in on 3 and 5 for the purpose of our conversation today. I'm not saying that those other ones aren't important or we need to work on those or we do those well, but what I really see 2 areas that are very critical for intervention, so that's delivering the instruction, is number 3 and number 5. And I'm going to start with number 3 first. So instruction during intervention should be explicit and systematic. People are pretty much understanding that, but that recommendation went on to include providing models of proficient problem solving, verbalization of thought process, guided practice, corrective feedback, and frequent cumulative reviews. And this is where I want to dig deeper into this, especially design instruction, differentiation, but this idea of frequent cumulative review. What I'm finding in my work with schools is this is a pretty disconnected idea. And it's not that teachers aren't trying to do cumulative reviews, it's just the way they're doing it is not aligned with the cognitive research that we have out there. What is the purpose of cumulative review? It's a recommendation. You should be discussing it in your RTI MTSS plan. What is the purpose of cumulative review? It's about retention. So cumulative reviews is about retention. So this is where differentiated instruction or instruction in general has to have a different slant to it. So retention is the amount of information kids are able to remember. Now this is definitely has an impact in tier 2, but we're not really looking at it that way. Most of the time when we look at kids in tier 2, they're placed in there because of some data that says they're struggling. So when teachers begin to look at that data, they're immediately making decisions about what they need to reteach. So this is where we have to have some subtle differences. Reteaching is different than something you would do for retention. Now, clearly, there are a lot of kids in tier 2 that need retaught, but there are also things that need not to be retaught, but need to be addressed through retention. So a major part of teaching is getting them to learn new content, but we also have to come behind that with some very, very specific things to help them remember it. Teachers are really not being evaluated on what they teach kids. Now that's kind of weird at its face value, but they're being evaluated on what kids are able to remember. So if you think about these evaluations that we have, they're usually at the end of the year. So you could be a wonderful teacher and teach it initially and get them to proficiency, but if you don't do some specific things to help them retain it, that is not going to show up on that assessment or that measure. So we've got to focus on putting content in, but we also have to focus on taking content out and in a non-testing situation. And that's sort of what I want to capture, retention. And if you talk to teachers at any level, they are going to tell you kids aren't retaining. Teachers are doing things to help with retention, but where the disconnect is, what they're doing is not really aligned with what research says should be happening for retention. So this is where I think the pre-service training programs need to come into play here in terms of making sure teachers know these techniques, and then there's implications for what's happening currently in the field. So there's this figure here that's called the forgetting curve. And this is how quickly kids forget what they've been taught. So most teachers are not really in tune to this forgetting curve. They're more in tune to how long it takes kids to learn something. So in this forgetting curve, or this learning decay, kids will forget almost 80% of what they learned in as little as 10 days. So if you have assessments that are spread out and you start testing kids, you're going to show gaps or deficits. Right now in an MTSS model, we tend to go about that from a reteaching perspective. In terms that they didn't learn it, we have to reteach it. When the reality is there's a good portion of that, it's probably more of a retention issue versus an instructional issue. And I don't see retention being a major focus in a lot of MTSS RTI models in math. A couple things with math here is there's some things in math that once you learn it, you'll constantly use it. So this forgetting curve is not going to apply to that content. But things such as geometry, aspects of geometry, measurement, probability, statistics, things that you kind of spend a concentrated unit on and then move on. These are things that get lost. So this forgetting curve definitely has implications for tier 2 as well as tier 1. I see this as something that has to be happening in both of these tiers. With retention, you really have to have some purposeful planning of activities directly focused on retention in both tier 1, 2, and 3, but the primary emphasis really needs to be in tier 1. This is something that is an area that I think a lot of tier 1 programs need because programs aren't doing this. But what we know is typical review and practice techniques are ineffective. What I mean by typical is what happens the day before the unit or chapter test. The teachers do a what? A review. And what are they reviewing? Well, they're reviewing everything that they just taught. And if you really ask the teachers what's the purpose of that review, they're going to say it's to pass the test. So notice they're not saying to promote long-term retention of important mathematical concepts and skills. It's a short-term boost. Then if you go into schools the month or two before the end of your test, then you're going to see this mass cram session. They're reviewing everything under the sun to try to pass the test. None of those are very effective. So there are 3 strategies, 3 ways to structure practice that directly address retention. And the first one is called interleaving practice format, IPF. The second one is called spaced learning over time, or the SLOT, and then practice test retrieval, PTR. Now, a lot of times retention is getting rushed because of the pacing and all these. So we're sort of in this catch-22 is if we stop and do some retention activities, are we losing content? The problem in math is we're losing that content because some of it is due to retention. And that if we spend a little more time focused on retention, then we would have less deficits to be filling kind of scenario here. So my take in sort of looping back to the pre-service programs and the practicing teachers, I was in a school district, which is a rather strong school district. So this isn't a needs improvement school district. And I had a good combination of veteran teachers, mid-career teachers, and brand new teachers. And we started talking about retention, and none of them had heard of any of these techniques. So I think this is speaking to the disconnect between some of the research base that's been emerging and what's happening in pre-service programs and what's happening in classrooms. I'm just going to get into this IPF. And the idea here is intensify in intervention. This is where math comes really into play. So those of you that are like curriculum coordinators or working with schools or seeing the curriculum, what's happening in tier 1 or tier 2, practice is a key element in math. Teachers use practice for a lot of things. Sometimes it's in homework, sometimes it's in class, sometimes it's through the computers. Younger children, it's sometimes through stations. But what I want you thinking about is practice. When you think about practice, there should be specific purposes for practice. Is the purpose of this practice for acquisition, so initially learning, or is the purpose for retention? Although that is a subtle difference, it is a huge difference in terms of how you do this. So we have there's a structure that is called blocked or mass practice. Definition of blocked or mass practice is when kids are practicing the same type of problem consecutively. So I have A. So all the A's are the same problem. I don't know, order of operation, or graphing a linear equation, or using a tens frame to count a number. They're all the same. When you see kids practicing the same type of problem consecutively, that is called blocked practice. Now, block practice is very important in the initial acquisition of learning. In other words, it helps kids become proficient and learn the skill in the moment. But what we are learning, or what we've learned from this, is block practice does not produce long-term retention. So you can have kids, if they get into block practice, they'll show that they have proficiency, they can do it, but that doesn't last. So if you come behind that a week or 2 or 3 weeks later and you give them a progress monitoring measure, it may show up as them not knowing how to do it, when the reality is they knew how to do it, they just haven't retained it. So as I see tier 2 classes and tier 1, I would say that the vast majority of practice that I see kids doing is blocked. So this is this sort of disconnect. And if all we do is block, they're not going to retain it. So the other form, this interleave practice format, literally all that is required for this technique is to resequence the problems. Like I have my block diagram up there, where each color is a different problem type. And what is happening now is the kids are not practicing the same problem consecutively. And what we're learning is this creates a deeper learning or remembering of the skill or the type. So when kids do block practice and they practice the same problem, cognitively what is happening is they see it's the same problem, they stop thinking. They literally stop thinking about it and they just solve the problems. There's no discrimination, there's no any thinking about it. With this mixed up practice, what happens is it slows the kids down at the cognitive level. So when they see a problem and they solve it, they go to the next problem. Cognitively, they're going, oh, this is a different problem. And it makes them pay attention to the critical attributes of the problem. And then they have to do this retrieval of the process. And it is that mixing it up, that small variable of simply mixing the sequence, creates this much longer, stronger, what is called durable learning that lasts across time. So as I see my pre-service teachers, as they come over, and again, this is just my one unique situation here at Penn State. I teach undergrads that are straight special ed majors. So we're their initial cert. But I also teach graduate students. They're already certified elementary teachers. And when they come over, so that means they've graduated, they're certified, they've had a math methods class, they've had instructional classes. When we talk about retention, they have never heard of these things. And I don't think that's that much different across the board, because when I work with practicing teachers, they have not heard of these techniques either. And when they start going back and looking at how they practice with their students, it's all falling under this block category. So I wanted to give some resources that are recent. So the first one, which I think is an exceptionally good resource for pre-service programs, is this retrievalpractice.org. This retrievalpractice.org is putting out these practice documents of how to implement retention. So it's free, which I always like free. It's written in a way that is useful to the practitioner. In other words, it's not all this heavy research jargon. And it really gets at how to do this. So that's the first resource I would like to get into your hand. The second resource is not free, it's a book. And it's the book there that's called From the Laboratory to the Classroom. That's where a lot of these strategies are discussed, explained. The research is in there now. I read this book 3 years ago. It had a profound impact on me in terms of what I read in this book, in terms of how to help kids practice in a way that promotes durable learning. And what I realized as I was a teacher, I was not doing many of what should be happening in terms of retention. So that's a wonderful book. It's a little more researchy in terms of getting into the nuts and bolts, but again, an exceptionally good resource. And the third one is the Teaching Exceptional Children special issue that came out on practice. This one is, I think, probably a bigger issue than the first one. Because the first one, those techniques are fairly simple to learn, a little to implement planning. But I want to talk about number 5 with this idea of visual representation. So everybody reads visual representation, we've got to use manipulatives. Well, it continues by saying interventionists should be proficient in the use of visual representations of mathematical ideas. And I think this is a significant problem that I experience at the pre-service level with my own classes, as well as when I enter the field, and that is teachers' use of visual representations is not as well developed as we think it is. So as soon as you hear visual representation and you're in an MTSS or RTI discussion, CRA immediately comes up as an intervention. And it's an intervention that leverages the visual representation in a very ordered sequence that takes them from the concrete manipulative to a pictorial representation to the abstract. And the idea behind it is it supports the understanding of the abstract procedure. And that's been recommended by many organizations in terms of an evidence-based practice. But there's also other visual representations that maybe aren't in that sequence. And that's where you start using like measurement models, area models for fractions and rational numbers. But this idea of this visual representation is really dependent upon the teacher and how well the teacher is able to model the math content. And I think this is where pre-service programs have really fallen short to some extent, is that teachers really struggle with this. Now, and I can use myself for an experience. I was more at the middle school or high school, so my representations were on the coordinate system. If they weren't on a coordinate system, I would have a hard time coming up with it because I'm at the abstract level. Just because you're at the abstract level, in other words, you can do the math, doesn't necessarily mean that that translates into you be able to represent it very well. One of the questions I want to pose to those of you in the field, how are pre-service programs addressing the use of visual representations? Are they really on a scale of 1 to 5, the teachers that you're working with, are they adequately prepared to enter into a tier 2 situation where they have to begin to do visual modeling of the mathematical concepts in a way that is going to take the kids through the progression? This idea of visual representation, the idea behind it is the ability to express mathematical ideas using visual representations and then converting them to representation. That's the symbol notation is important for math. So in order for interventions to do that, there's really 2 variables that are involved: their own understanding of math and how to use the representations. Now, if you've been paying attention to fractions and what has sort of happened with the standards over the last several years with fractions, is we really began to funnel kids to the visual representation of a number line. The number line is a better visual representation of fractions versus circular only. So this is sort of getting at this piece here. And this is where I think the research has been here for a while that is suggesting that pre-service teachers, and in some instances in-service teachers, sort of lack a depth of understanding. Now, this is sort of a hard discussion to have with the teacher, because you're basically saying, well, you don't understand math. Well, it's not really that I'm saying that. It's that there's procedural knowledge and then there's the deeper conceptual knowledge. And what the research has really shown in the 90s, now this is old, so it's got to be better now, is that we have teachers that can do procedures. So for example, they can multiply fractions. The deeper question is, are they able to use a visual representation to model what is happening with the fractions? And that's where this tier 2, that's what's happening in tier 2, is we need more visual representation. That's the 90s. There's got to be newer research. Well, the newer research I find interesting. When they survey teachers, 70% say, I am comfortable with it. 40% of special ed teachers say, I feel comfortable with it. So that's less than half the special ed teachers, which are often interventionists. 30% of the general ed teachers. Now, this is self-report. So obviously, this is probably going to be inflated a little bit. But when you go a little bit deeper, they're only using manipulatives 1 to 4 times a month. Visual representations are critical, but do the teachers know how to use these? So the use of visual representations is a little suspect. Knowledge, a recent study that I shared was at 2 major universities in the United States, and we looked at pre-service teachers' ability to represent fractions. And what we found is exactly what they were finding in the 90s, and that is teachers can do it procedurally, but they cannot come up with visual representations. So this has a couple implications for an RTI MTSS plan. That is, since we need to use visual representations in tier 2, we're showing that teachers have difficulty with that. You're going to have to think about PD opportunities for that. You're going to have to think about, do you have intervention materials that have explicitness for the teacher? Use this manipulative. This is why you use it, and so forth. Because if you don't have that, this is really going to have some implications into how well it works. A good analogy is if you give me the best state-of-the-art woodworking materials, but I have minimal knowledge on how to use woodworking materials, those tools are only going to get me so far. So I think this is huge, because we all know CRA is something that is important for tier 2. Some will argue for tier 1. But what the question is, I think the teacher's comfortableness, depth of knowledge is probably not where it needs to be. So I think pre-service programs need to boost. And that's something that I have tried to do in my math methods class that I teach, is do more of that manipulative work. And what I find is kids struggle with it. They can do the procedure, but they have difficulty representing it. So I think this is something at the state level or at the district level, in the context of an MTS RTI model, you got to pay attention to, because I think teachers are not as well prepared to use these representations as we thought they were.